You can start. Shall I?
Yeah, you can start.
Okay. Thank you, Dr. Jimbo, for this opportunity, and I welcome you all to my presentation. In today's presentation, I'm going to talk about the time until adoption of laser lamp level technology, which is one of the conservation technology that can be used to conserve surface irrigation water. Before starting my presentation, let me start with the phrase by.
We just mute Jumbo's computer, just so we're not getting feedback going back out through him.
Oh, I'm gonna do that.
And then we'll have to open this up again when people want to ask questions. Or not, if you don't like.
Yeah, but
Be muting the speaker.
it's good to have the mic.
Hello, we cannot hear.
And then possibly start again from the start, so we cut all of this out, so that when
Okay.
on the red.
Okay, now it's fine.
So just
That's
turn
it.
down the speaker volume on your computer, not
Yeah,
the
yeah,
instrument
yeah.
on your computer.
That's all. Everything is done.
I can still hear it.
But then I turn off the. That's it.
We're getting this echo coming through.
But
Out of
I-
your computer.
I think if you mute the system, yes, I think mute here because.
Because I muted that on my computer.
But you haven't muted the playback from your computer because we can still hear stuff coming out of it.
But I've got to mute one way or the other, or the speaker or the microphone.
Not the mic, just the speakers.
Yeah, mic is on now,
Good.
and the speakers is off, completely off.
How come we can hear it?
What you can hear is it coming out, is the
Is
speaker
it not?
coming out of,
Yeah.
it seems,
So then turn down the volume on that thing.
it's the internal speaker on that, which is who we're hearing.
Alright.
This bloody hell, what they did on this.
Yeah, no, that's just the mics.
We turn down the volume of that on that computer. Why is this?
Mic volume, speaker, that's not. Hold on, hold on. Ah. Is that the one? That's the speaker.
I think.
Let me try it now. Hello.
Yeah. Bloody hell.
Let's just, let's live with it. I think.
Yeah, kind of losses.
Or the other way would be we just record it and people who are here.
They can hear us now?
Yes, we can.
Yeah, echoing sound.
But you have
Hello.
to-
Are you okay with that coming out? Can
I'm
you-
okay.
Okay, let's do it.
So shall I start from the scratch
Yeah,
or?
start from the beginning.
Okay. Thank you, everyone, for being here. In today's presentation, I'm going to talk about the time until adoption of laser land level technology, which is one of the conservation technology that can be used to conserve surface irrigation water. Before starting my presentation, let me start with the phrase by Benjamin Franklin. He says, when the well is dry, we know the worth of water. And we know that water is a vital natural resource, but it is becoming scarce around the world. The availability of water is diminishing through frequent droughts and overexploitation of groundwater. However, if the business as usual continues, that would affect about 2.5 billion people by the year 2050. Agriculture is the main user of water resources in South Asia, where irrigation water is a limiting factor in the production. And to meet crop water requirement, the region is heavily dependent on groundwater for irrigation, leading to a rapid depletion of groundwater and increase in secondary soil salinization. In this region, farmers have been practicing ancient method of flood irrigation, which is a least efficient method for irrigating crops. In this picture, the flood irrigation, which is one of the example where water is applied and distributed over soil surface by gravity. Experimental research has shown that about 10 to 25% loss in irrigation water is due to unleveled fields, resulting in an uneven distribution of irrigation water across farm plots. Only through better farm level management practices, efficiency in surface irrigation can be improved by up to 85%. And a simple management remedy is the leveling of unleveled fields through laser land leveler. Compared with conventional methods of land leveling, laser land leveling is a more precise technique and increasingly being adopted by farmers or land managers in South Asia, particularly in India and Pakistan. In Pakistan, laser land leveler technology was introduced in 1985 with the objective of increasing surface water irrigation efficiency. Since then, the government has launched 2 subsidy schemes, and in both schemes, laser land leveler units were distributed among land managers and private service providers at a 50% subsidy on purchased cost. However, the only difference between the 2 subsidy regimes were that the recent subsidy regime was conditional, that there was a requirement that the beneficiary should bring at least 300 acres of village land under the laser land leveler technology. The experimental research has identified some direct and indirect benefits of laser land leveler technology. Some direct benefits include it can improve water application efficiency, it can improve water productivity, it can also reduce water runoff. Some indirect benefits can also be achieved, such as it can save energy cost, it can enhance fertilizer cost of use efficiency, it can increase crop yields, and ultimately crop income, etc. However, a soil science study has reported negative impact of LL technology on soil volumes and crop root growth. On the other hand, in the non-experimental research, a few studies have evaluated the indirect impacts of laser land leveler technology using endogenous switching regression methodology and propensity score matching. Only one study has evaluated the direct impacts in terms of the number of irrigation saved using ESR and PSM methodologies. This indicates that there is a research gap in the non-experimental research that no study has evaluated or quantified the volume of irrigation water saved. Similarly, there are few studies that have investigated the factors that can influence land managers' decision to adopt LL technology using binary logic models. Only one study has employed double hurdle model to investigate factor affecting decision to adopt LL technology at the first stage and factor affecting intensity of adoption at the second stage. However, in our knowledge, no study has investigated the factors that may reduce or increase the time until adoption of laser land leveler technology. Therefore, in this study, we investigate the factors affecting the time until adoption of laser land leveler technology in 3 irrigated cropping zones of Punjab, Pakistan, and evaluates the uptake of laser land leveler technology under different government subsidy regimes and its impact on volume of groundwater saved. The study is conducted in Punjab province of Pakistan that covers about 57% of the total cultivated area and accounts for about 73% of the bulk cereal production in Pakistan. The study covers 3 irrigated cropping zones, and a total of 504 farm households were interviewed and used in the analysis. In the theoretical framework of the study, we assume that land managers are rational and they want to maximize benefits out of the technology. Land managers will adopt laser land level technology when the expected net benefits are positive. And with the adoption of laser land level technology, land managers can perceive to drive some benefits in terms of volume of groundwater saved. However, each land manager can perceive benefit differently based on their socioeconomic characteristics, agronomic practices, etc. The expected unobservable net benefit variable is a function of observable exogenous variable in a latent variable model can be expressed as. However, instead of observing unobservable net benefit, researchers or analysts can only observe dichotomous variable with the value of 1 if the land manager is an adopter, otherwise 0. In order to evaluate the volume of groundwater used to irrigate the wheat crop, there is an issue and there is a challenge here that how to quantify the volume of groundwater, as there is no mechanism available to monitor its extraction at the plot level. So therefore, we employ an approximation equation to estimate the volume of groundwater extracted in terms of metric cubic per acre, where TI is the total groundwater irrigation time in hours, BHP is the power of engine in horsepower, and DI is the depth of bore in meters, and DM is the diameter of the section pipe in inches. Now we assume that the outcome equation, which is in our case volume of groundwater, so outcome variable is a linear function of some exogenous variables and binary variable for adopters and non-adopters. However, 2 potential issues may arise here. One is the self-selection bias, and second one is the endogeneity problem. To cope with these 2 problems, we employ an endogenous switching regression, which is a 2-stage model. In the first stage, in the selection stage, the decision to adopt LL technology or not is a dichotomous function. And in the second stage, 2 outcome equations are estimated for both adopters and non-adopters. After the proper identification of the model, these two stages are simultaneously estimated via full information maximum likelihood estimation. After estimating the model, observed and unobserved counterfactuals for adopters are estimated, where counterfactual scenario for adopter explains that what would be their land manager's outcome if they had not adopted the LL technology. Finally, we are interested in the average treatment effect on the treated farms to estimate unbiased effects. To check the robustness of our findings from the ESR model, we also employ propensity score matching. Events are often discrete in agriculture, as land managers do not use a technology continuously over the production year. So the discrete intervals are usually reported in integer years, making the discrete time duration model more suitable to examine the dynamic nature of the adoption process. The common proportional hazard model assumes a multiplicative relationship between the baseline hazard, which is time dependent and common to all land managers in the sample, and covariates, which is a relative hazard, conditional on covariates and vary across farm households. To estimate this equation using discrete time duration analysis, we parameterize the hazard function using complementary log-log specification. In the complementary log-log specification, it transforms multiplicative function into a linear function where Vt is the time variable capturing the effect of time duration dependence, and Xi is the exogenous variables, a vector of exogenous variables. In the discrete time duration model, dependent variable is a dichotomous variable. Before estimating this discrete time duration model, first we need to organize the data into percent time format for each farm households, where each farm household has multiple variable rows since the introduction of the technology up to the year when the adoption occurs, and or a sensing time at the end of the study period. Out of total farm household, about 70% had adopted LL technology in Punjab, Pakistan. If we look at the pickup probability of adopters, almost 62% of adopters had adopted LL technology within 10 years. The interpretation of complementary log-log model is quite straightforward. The coefficient, the estimated coefficients are the hazard ratios, where if the hazard is greater than or less than 1, that implies a negative or positive influence on the likelihood of adoption. And if the hazard ratio is equal to 1, it implies there is no influence on the likelihood of LL adoption. In our study, sources of information plays an important role in the promotion of LL technology among land managers. It helps land managers to evaluate the benefits and cost of the technology and dispel any misconception about the technology. Information relative to social networks, information acquired through formal sources of information or informal sources of information reduces the time to adoption. Relative to no formal land entitlements, secure and legal land entitlement reduces the time to adoption, where secure and legal land entitlements encourage or motivate land managers to do short and long-term investments. If the LL rental market is far from the homestead, it increases the time to adoption of laser land level technology. Relative to no subsidy regime, the government subsidy during the period of 2012 and 18, it significantly accelerates the speed of adoption of laser land level technology among land managers, because that subsidy regime was conditional. And as I have earlier mentioned during my introduction, that there was a requirement that the beneficiary should bring at least 300 acres of village land under the laser land level technology. We model the baseline hazard as a log of time duration. We find that there is a negative duration dependence, which implies that the probability of adopting LL technology falls longer for those land managers who have not adopted it. The adoption of laser land level technology has significantly reduced the groundwater application to wheat crop by 22%, which is equivalent to a net saving of about $3.5 per acre. ESR findings are consistent with the findings from the PSM methodology, irrespective of the matching algorithm used, we find that the groundwater application to wheat crop has reduced to within the range of 19 to 22%. From our findings, we suggest that the provincial government can accelerate the ongoing efforts in digitizing the land record system and improve and facilitate the process for land managers that may further accelerate the adoption process. Adoption may be further accelerated through improved information delivery mechanism, through extension services and participatory methods, where interactions can be extended to all stakeholders at the village level. Government should identify hotspot areas where the adoption rate is low and support conditional subsidies. Last but not the least, the study contributes to the literature, to the broader literature on the agriculture innovation adoption. Very quickly.
I'm monitoring the chat, into which I've put a question, which is, could you go back to the results a couple of slides ago? Yeah. So there's two different subsidy regimes.
All right.
I understood what was going on with the later one, and you can see it's had a big impact. What was the nature of the earlier subsidy regime, and why is it having no impact?
Yeah, so the earlier subsidy regime was conditional. Sorry, the recent subsidy regime was conditional, but the subsidy regime during 2005 and 2018, the government just distributed laser lab level unit.
Okay, it was a general subsidy.
General
not
subsidy.
a subsidy for laser lab.
Yeah, general subsidy. But in the recent subsidy regime, there was a condition that the beneficiary of the LL unit should bring at least 300 acres of their village land under the laser lab level technology. That was a different way because of the conditional regime. That's why we suggested that in the policy implication that the conditional subsidy regimes works better.
So even that wasn't a very direct subsidy. It was sort of a conditions were placed on it that then had to work its way through the village system, I suppose, the leadership.
Yeah.
It's like a village leader, was it? Who then had to encourage them? Is that how it worked?
No, there is no community setup available,
Okay.
but it's open to all.
How
But
big-
sometimes
how big are these farms?
if we look at the farm size, large farm size here,
12.5.
so it increases, so it reduces the time to adoption if they are large scale farmers.
Yeah.
So here we have, if they have farms with greater than 12.5 acres.
Yeah.
So we consider that, so the less than 12.5 acre farmers, because large farmers have easily access to the markets, the rental markets. So that's why their adoption is higher than compared to small scale farmers.
Just to follow up on that, so what happens if they don't achieve the outcome? You say the subsidy was contingent on them achieving
300 acres.
What happens if they don't?
So
Is it coming in afterwards? As in, is the subsidy appearing once you achieve that level? Or
Well,
is it, what
Well, in the reports, in the government reports, they didn't report it that, they didn't report it and they didn't monitor that, actually, that whether they have achieved 300 acres after getting the LL unit or not. But there was a condition that they should bring.
So the 300 acres, that's about, whatever it is, 30 farmers or something. Right, so
Well, it depends, within a
so
village.
it's
It's a mix, it's a mix.
some number of farmers.
Yeah.
So you have to get a group of farmers to all cooperate. Otherwise, none of them get meant to get the subsidy. Is that how it works?
Yeah, sometimes they collect funds from all farmers so to get benefit from this subsidy, and then they can use it in the village.
So the subsidy is given to the farmers or the one who purchases them?
There is no limitation. It can be distributed. The subsidy was distributed among land managers as well as private service providers.
So I'm asking this question because I'm curious about the pricing. Because if the service provider only gets the subsidy, then the service provider some service provider may reflect that subsidy amount in the pricing. If a farmer is hiring particular machinery, they might be hiring for 500 Pakistani currency per hour or something like that. But if they get subsidy,
but there is a homogeneous rate within each village. So for example, if in village one,
subsidy.
no, not for the subsidy, it's about rental charges for LL technology. So for example, the rental charges are $15, and it depends on the type of land. Sometimes laser land level required for 1 hour, for some plots for 2 hours, for 3 hours. So it varies. The cost varies depending on their type of land, but the rental charges for an hour is same.
I still now don't understand how the subsidy works.
Yes,
I think
me either.
the more so a village, no subsidy exists. They now become eligible for the subsidy. What happens?
Who gets paid?
As in, where does the money come? When does the money get paid? Where does the money come? The subsidy is coming from government.
Subsidy is coming from government.
Okay. So there's somebody sitting there, there's a stereotypical government person sitting with a bag of money. They're going to transfer that across to somebody in the village or people in the village. When and how and under what circumstances does that money move from the government into the village?
Into who?
And yeah.
This is important to be clear about, I think, because this is the factor that has the biggest influence. And the way you've described the way the subsidy works sounds a bit unusual, at least to an Australian, it sounds unusual. And so it would be really important for your readers to get a clear understanding of exactly how the subsidy works, the mechanics of the subsidy.
Okay. So in the government reports, they just mentioned that there are conditional subsidies, but how it works, it can be possible that within the village, 2 or 3 farmers can get the subsidy, depending on their financial conditions. They can get.
Why are they getting the subsidy? What have they done to get the subsidy?
To provide services for the farmers in the village.
So there's people turning up saying, I've got this piece of equipment. I'm going to provide a service.
Provide a service at the village level.
I've got some proof. I own this piece of kit. They go to the government and say, now give me the money. Give me a certain amount of money.
Yeah, so it's a ratio of 50-50%, not all subsidy.
Okay, so
I'm going
to buy a piece of kit, and
so it's a 50% subsidy on purchased cost. So it means that 50% is coming from government and 50% is coming from farmers.
Okay, so I don't have a machine. I now buy a machine. I go to the government and say, give me half the cost of this. And the only requirement for the government to pay for it is the fact I bought the machine. And at some stage, I have to have leveled 300 acres.
Right.
But the 300 acres, that's going to happen later. And we don't actually know whether or not it's, if I buy the machine and just then put, for some reason, don't do anything with it,
But
I still get
so
the
it's so it's better for them to to give some services for other farmers,
Yeah.
because they can only use during one season. So but yeah, so it can be repeated after 3 or 5 years.
So it's an assumption that I am now going to, it's on the purchase price. I've now got the bit of kit in the village. There's now an assumption that I am now going to provide that service at any cost. There's no restriction on what I charge everybody else.
Well, you said it was $15.
It's a 15, yeah. So it's a range between $12 to $15
The
Australian dollars.
government isn't saying you have to subsidize the delivery. I'm assuming now going to deliver the service because I can, because I've got a half price machine.
It's sort of a local monopoly. Maybe.
Yeah, but not every farmers can possess tractors.
Yeah.
So large farmer probably get benefit from this subsidy. And
So with the data that you've done for the statistics later on that we were looking at, I'm now puzzled as to how that works, because that data is for individual farmers,
individual
but
farmers.
the subsidy applies to the person who provides the laser leveling service.
No, we don't know in our sample whether they are service providers or not. So what we did,
How do you, what does your data look like? To get a one, get a one for that variable, yes. Well, I'm not even sure what the data is.
so
You've leveled your land.
Oh, you have leveled it.
Well,
Okay,
you could be you or it could be.
okay, so that's the dependent variable. What's the independent variable? The independent variable,
is it
which
is a
records
zero-
whether or not a subsidy is.
yes, 0-1
But just 50
during
years.
the years.
Within, for you,
No,
for your region, for your village.
for the country.
Oh, for the country, oh, right.
Yeah.
So the country had a program in place.
Okay,
And Julius, that feeds its way through. Some villages may have taken it on and may not, and then you may actually use the service provider to do it.
okay.
But it's just like a
It's
really,
very crude.
it's a top level
Yeah, okay.
success of the program.
But then that
It's sort of
visual
what you want.
analysis becomes very crude, because the risk is not on farmer, exposure is not really on farmer.
It's detecting whether or not this subsidy paid, however it was paid, to whoever it was paid, has flowed through and had an impact on ultimate adoption. That's what you're measuring.
Yeah.
And it has.
And it has.
And you know nothing about the intermediate steps as to whether who
Yeah.
was actually doing it,
Doing
who actually bought it, where they were buying it. You're just assuming that in principle that
By some unknown mechanism, unknowable mechanism, it has had a strong influence.
all right. Those who had adopted during this subsidy regime, yeah, that's why.
and there's an inference that there was nothing else going on 12 to 18
That's
that
true.
was causing it. This is that it was all due to the subsidy rate. The effect that's being picked up is all being attributed to the subsidy regime.
Subsidy.
So you've represented the subsidy regime as a 1 or a 0, and you get a 1 between 2012 and
2012 to 2018, yeah.
So, okay, so
So other-
anything else could have been happening then as well, other than the subsidy.
Yeah.
Including just the progress of diffusion of the technology.
But that's picked up by the log of time.
Yeah,
Is
It suddenly happened. But
the data is cross-section or you have multiple stations over time?
it's converted into pseudo panel data set. So it's like for each farm household, there are multiple entries since the introduction of the technology up to the year when they adopted it. So there are series of zeros until it terminates at when the adoption occurs.
Yeah, but this is for the duration part, right? This is
Yeah.
The duration analysis, I'm asking that for the mine analysis, the 2-stage analysis, do we have cross-sectional duration or you have multiple duration of the farm?
Cross-sectional. we organize it for discrete choice and discrete time duration model. We organize it in a percent time format
But the impact on water use.
or section
that's
data.
just cross-section.
Cross-section
Time
data.
at which you've surveyed them. You just know how much water they use, nothing going back.
I'll just ask, are there any other questions in the round here?
I have a question, please.
So in a village, how many service providers are there generally? Because
In the village,
Yeah,
we don't have such data.
so you don't have service providers.
We don't have such data. We ask just that how much they have paid in terms of cost.
Because in your result, it is showing that distance to service provider has no effect on duration of analysis.
Sorry, where?
Distance to range of markets, it's one. So
It's
it is saying
it's a
that
it's a distance variable in kilometers.
Yeah, so it is, so from.
Yeah,
later
so
counts, right?
yeah, so distance to the laser land level market. So distance.
Because I'm also doing similar analysis, and in my analysis, this distance to range of market is a significant variable. It has good impact on the speed of adoption because
Good depending in what terms, either reducing the or increasing the time.
reducing the time of adoption, because if there is no service provider in the nearby distance, they come from far, and it is reflected in the price and time availability of the service. Seems like.
But you couldn't find any heterogeneity in your price data because at the village level, in village 1, there will be more or less same price. In village 2, there will be more or less same price.
I think the thing is that the distance, whether the distance effect is a proxy for the price within a village. So across the villages, if you're a long way away, a whole village is a long way away.
There is a
from
transaction
village,
cost.
then they're going to be less likely because everybody's prices are higher.
Yeah.
But then I think the other thing is that distance, this is a problem with units. Is that significant for you? It looks at the dots on
Yeah,
the line. but
Well, it's because of this large, yeah, because
so
of the
I think
that.
we scale it.
Although it's close to 1, but near 0.9.
But that's going to depend a lot on the units. So I think you could make that.
Yeah.
You should get it.
Okay.
I think because although it looks as if it's well, I think it actually is significant, isn't it?
It's significant. It's statistically significant, but in terms of
But it's one, so.
not
But
1.
it's significantly different from one.
Yeah.
So you can't see it on the graph because of the scale.
So
Just like log of time duration. The value is 0.8, so it's like close to 1, right? But it's not. But it's significant.
Amin has a question. I'm not sure, we've had trouble with our.
You won't do them.
Amin wants to ask a question. Sorry? Amin wants to ask a question.
Can you hear me?
You can start.
Can you hear me now?
Yes.
Okay. First, I think it's just a point of maybe telling you in the beginning. I think it would have been more clear if you just provided motivation in terms of the subsidy, because that would have cleared a lot of things when it comes to interpretation of how that was computed. Having said that, I think the first question I want to ask is how many villages, because it seems like you are saying this subsidy regime in 2012 to 2018 was based on villages. So how many villages did you have? And if that is the case, then I'm just wondering whether you need to control for the clusters of villages rather than, I'm not sure how that was captured. Maybe you captured it based on individuals, based on the village. And I don't know how many villages you have, but if the villages are not so many, then I'm just wondering whether you should look at it from a multi-level perspective, where you're modeling things at the first level, it's at the farm level, but then at the next level is at the community level, where the community here is the village. And therefore you need to control for that maybe at the village level, because the subsidy then is going to be distributed depending on the type of village.
Okay, so there are 38 villages in our sample.
Okay.
And
Okay.
sorry?
You go ahead. Yeah, so I think 38 is a little bit, so given your total sample size, then maybe 38 is too much if we try to control for that. Yeah, so I'm not sure, but maybe it's something that you need to rethink, because the way you are explaining that to me, I think it's not clear still at all. It seems like you're contradicting yourself, the way you started at the beginning and the way you ended in terms of you are explaining how that subsidy is captured. You seem to be contradicting yourself. So there needs to be more clarity in terms of how that is captured. And what do we really mean here by subsidy? And how did you end up determining who received the subsidy if this was done at the village level?
Okay, I will do that. Good suggestion. Yeah, thank you.
Questions? Anyone on Zoom? Do you have questions? No, Dave is.
No more, nothing in the chat.
All right. Okay.
No more questions. Thank you for the
Thank you.
presentation. And also thank you for
Yes.